Today we're going to work with polynomials and inequalities, and this is actually a very good topic for a pre-calculus student because of what happens in calculus. And one of the first things that we need to understand is, let's say that I've got some graph of a polynomial. Go ahead and sketch that graph. It's very, very important, and it sounds like a fundamental idea, but believe it or not, people struggle with this idea. And it's this idea of the value of this function. We're going to be calling them functions from now on. This is a polynomial function. This would be a cubic of some kind. If I wanted to talk about the values of this polynomial function over here where I've got this red line, what's one thing I could say about them? All of these function values over here are what? Negative. It's very important that you understand that all of those function values, and by the way, we're going to be using the term function values a lot more than y values, but know that those are the same thing. Okay? Function values are the same thing as y values. Okay, so when I talk about function values, I'm really talking about what are the y values of the function. Now, right here on the x-axis, of course, the value of the function is 0. Okay, right there. That's the value of the function right there. We call that an x-intercept, but we can also call it a 0. Now, what is the value of the function here where I've drawn the blue? What can I say about it? These are all positive values, right? All the function values are positive. We're not talking about x values. We're talking about function values. So one of the things that's important that I want you to see right here is at this 0, the function values change sign. Okay? The function values change from a negative to a positive. All right? And then we have another 0 right here. Here's another 0. And lo and behold, the function values change to negative again. They're negative there. And then, lo and behold, we have a third 0. And the values of the function change sign again back to positive values. So I want you to notice that on this particular function, which is a cubic that has 3 zeros, it changes sign 3 times. Okay? It changes sign, let me get a different color, changes sign here, here, and here. All right? At all 3 of those. Very important that we understand that idea as we lead into what we're doing today. So, what are we going to be asked to do? Well, we're going to keep this pretty simple. These polynomial inequalities can get really ugly, and we just really don't need to go there. Solve and graph the solution. We're going to start with a very easy problem. Maybe it's not quite that easy, but it's the type that I want you to be able to do for our upcoming test. We're going to learn 2 basic types of problems. This is one of them. Now the first thing you got to understand is what this thing is asking you. It's asking, where is x squared minus x minus 6 negative? Okay? Where is it negative? When it says less than 0, it's asking, where is it negative? Okay? So right now, in your mind, you should have a mental image of what this function looks like. Isn't this a quadratic, right? Now, we haven't studied a lot about whether it's concave up or concave down, but I'll just tell you that since the a term is positive, this one is concave up. So what we've got here, let's just draw down in the corner, we've got some kind of parabola here, okay? So before I can tell where is it negative, I need to know what the zeros are. Okay, because obviously it's going to be negative down here. All right? So let's find out what the zeros are. This one's easy. So we're going to set x squared minus x minus 6 equal to 0. And we're going to solve it just like we did in this unit. This one factors pretty easy into x minus 3, x plus 2. So the zeros are at 3 and at negative 2. So now this is at 3 and this is at negative 2. Now, because it's a quadratic, it would be pretty easy to go ahead and go straight to the solution. But what you need to learn how to do is to also check some values. This is doing this problem, we would call this analytically or algebraically. So what we're going to do is we're going to kind of divide this thing up into, I made my line a little long here. We're going to divide this up into 3 regions. Here's 3, here's negative 2, and what we're going to do is we're going to check a value somewhere in those intervals just to verify what we think is true. So somebody pick a number less than negative 2. How about negative 3? Okay, negative 3. Negative 3 is less than negative 2. So what we're going to do is we're going to plug that in to our function. Okay, we're going to plug that into our function, into x squared minus x minus 6. So if I plug that in, I get negative 3 squared is 9, minus a negative 3, minus 6. That's going to be 12 minus 6, which is 6. And all we need to know is it positive or negative? That is a positive 6. That verifies what we thought. Over here at negative 3, the value of this function is positive 6. So over here, it's positive. Okay? Now, let's pick a number between negative 2 and 3. And what's the obvious, easy choice? 0. Let's use 0. So I'm going to plug 0 into x squared minus x minus 6. So I'll have 0 squared minus 0 minus 6. That's going to be negative 6. Lo and behold, we have found out that when x is 0, the y value is negative 6. So now I know it's negative over here. Now let's pick, we need to pick one more just to verify that we've changed sign. Somebody pick a number bigger than 3. 5. So let's plug 5 into our function. 5 squared minus 5 minus 6. That's going to be 25 minus 5 minus 6. 20 minus 6 is 14, and that indeed is positive. So over here, we've got positive values. So we have now analytically proven what we know to be true. We're supposed to find out where is this function negative? Well, we need to write it as an inequality. It's negative from negative 2 to 3. So we would write that as x is greater than negative 2, but less than 3. When the x values are between negative 2 and 3, the y values are negative. Okay? And that's the idea behind, really the whole idea behind what we're doing today. Now, we're just going to do one graphically with the graphing calculator, and then we're going to be done. So, let's graph and find the values. By the way, we're going to graph this with the TI-84. Graph and find the values of x that satisfy the inequality. All right? So they're going to give you an inequality like this one. Y equals 1/2 x squared minus 2x plus 1. Okay, so there's our, I said they're going to give you an inequality. They're going to give you a function, and then they're going to give you two inequalities. They're going to say, okay, when is it less than 0? And part B, when is it greater than 7? Now, we did some of these last week. Okay, it's the same idea as what we did last week with those absolute value problems. First thing we got to do is plug in the function. So let's go to our graphing calculator and plug in 1/2 x squared, which we can put 0.5 x squared minus 2x plus 1. Now we know that's a parabola. I'm just going to hit zoom standard for now and see where this thing is. There it is. Okay. Now, once again, let me get this to a place where I can write on it. If I'm going to answer part A, part A is asking where is it negative, right? Isn't that what it's finding out? Where is it negative? Well, it's negative right in here. Okay, that's where it's negative. We want the x values where it's negative. So all we have to do on this problem is calculate the zeros. Okay, so let's go back to our graphing calculator, if my Memio will cooperate, and do that. We're going to go to second, trace, and we're going to calculate these zeros real quick. Move it over to the left of my 0, hit enter. Move it to the right of my 0, hit enter, and then hit enter again. The first 0 is at 0.586, okay? 0.586. Remember that. I'm just going to go ahead and calculate the other one. Second, trace, 0. Move it to the left. Hit enter. Move it to the right of the 0. Hit enter. And hit enter again. 0.585 and 3.41. So this place is 0.585, and this place, this 0, is 3.41. So if I want to answer this question, it asked for the values of x that satisfy the inequality. So it's when the x's are in between these two values. So my answer would be when x is greater than or equal to 0.585, but less than or equal to 3.41. And that would be the answer to part A. Now, if we want to do part B, again, you need to understand what is it asking. It's asking where is it bigger than 7? Now remember, when we say where is it bigger, we're talking about y values, function values. All right? So just like we did last week, what we're going to do now is we are going to graph the line y equals 7. So let's add to our graph y equals 7. Okay, so on y2, you just We're going to graph the constant function y equals 7. And it's going to be a horizontal straight line through 7. All right? Now, again, I'm really trying to help you understand this idea of what we're looking for. Now, okay, it's asking for where is it bigger than 7? Well, it's bigger than 7 from here to infinity and from here to infinity. All right, but it's asking for the x values where that's true. So what we're going to do is we're going to calculate these two intersection points using the graphing calculator. And then we'll be ready to write our answer. So let's go back to the graph, and we're going to press second, trace, and we're going to select number 5, intersect. So you move your cursor close to that first intersection point. Get it as close as you can. And then you just hit enter 3 times because it says first curve, second curve, guess. That first intersection point is -2. Everybody remember that. Now we're going to do it again for the other intersection point, number 5. And I'm going to move my cursor over to that other intersection. Please be patient while my cursor takes forever to make the trip all the way around the sun. If it doesn't go too far. It did. Love it when it gets locked like that. Brings joy to my soul. Come on, you can do it. Sorry about that. You get it close to the intersection point, you hit enter, you hit enter, and you hit enter again. And it's 6. So our 2 points were -2 and 6, right? So that means that this x value is -2. That is the x value of that intersection point. That's the x coordinate. This x coordinate is 6. So if I want to write my answer, the question asks for the values of x that satisfy that. Well, the values of x where this thing is positive, it's going to be when x is less than or equal to -2, and when x is greater than or equal to 6. If I wanted to write that in interval notation, which we have worked on, an interval notation will be on the test, so let's make sure we know how I would do that. All of the x's, well, we're starting way over here at -infinity. So this interval would be -infinity clear up to -2. And then this one starts at 6 and goes to positive infinity. So we would start at 6 and go to positive infinity for that interval if we wanted to write it in interval notation. And that's all we're going to do for today. We'll stop there.